Tears of wine, or sometimes also called legs of wine, are a fluid dynamical phenomenon based on the Marangoni effect, which occurs due to a gradient in surface tension and was first described by James Thomson in 1855. It was only a decade later that the Italian physicist Carlo Marangoni generalized the idea of flows driven by interfacial tension gradients. Therefore, these flows are commonly associated with his name and account for a variety of processes. In this video, we'll be taking a closer look at the tears of wine and use them to demonstrate the physical principles behind the Marangoni effect. After pouring the wine, we produce a thin film of liquid on the sides of the glass. As can be seen by the shadow, in the moment we let the wine rest, droplets start to form at the upper limit of the film and flow down. At the first glance, it looks like the wine is just flowing back into the rest of the glass, but if that was the case, the flow would decay and eventually disappear. However, after a while the flow is still maintained and seems to even intensify. Taking a closer look, the shadow of the flow reveals a complex movement of the fluid, which can also be observed in the glass itself. But where does the flow get its replenishment from? This is where surface tension and the Marangoni effect come into play. Wine is essentially a mixture of water and alcohol. In general, alcohol has a lower surface tension and evaporates faster than water because of the higher vapor pressure of alcohol. The thin fluid layer on the sides of the glass, created by swirling the wine, has a larger surface area to volume ratio, which enhances evaporation compared to the bulk part of the wine in the rest of the glass. Since the alcohol evaporates faster, its concentration in the thin film is reduced, which in turn increases the surface tension due to the higher content of water in the film. The stress balance equation at a free surface states that a local gradient in surface tension equals a tangential stress at the free surface of the liquid and thus serves as a boundary condition for the Navier-Stokes equations, similar to wind forcing in the ocean. Initially, the stress due to the surface tension gradient is larger than the opposing gravitational force, such that there is a net force which accelerates the wine from the bulk part up the wall of the glass. This results in an accumulation of the fluid at the upper limit of the film and droplets start to form. Viscosity is also acting against the stress, but is neglected in this demonstration. The flow which is induced by the surface tension gradient is called Marangoni flow. As more and more wine accumulates at the top of the film, the droplets grow and the gravitational force increases. Eventually, the gravitational force exceeds the stress due to the surface tension gradient, and the droplets slip back to the rest of the glass, but with a depleted alcohol content. This process continues until the alcohol is completely evaporated. Some people claim that the tears of wine can be used to assess its quality. However, formation of the droplets depends on several factors, so that a conclusion about the quality of a wine cannot be drawn from them. In general, wines with a higher alcohol content show a more pronounced Marangoni flow, and droplets of sweeter wines flow slower down the sides of the glass. On the other hand, the temperature and cleanliness of the glass can also have an effect of the formation of the droplets.